arrows to show how products are formed in the acid-base reaction that is shown below. Here we have a reaction between a ketone and water and H2SO4. The first thing to determine is which of these molecules will act as the acid. And you can look at the pK values and see that H2SO4 is really the most acidic. It has a pK of around -3 and should be the acid. However, we know that when we have H2SO4 in water, we have no H2SO4 remaining in solution. So we should be using H3O plus for our acid-base reaction. The product of this reaction is already given. This is often a first step of reactions that you will learn later. So since the lone pair on the ketone grabs a hydrogen, we know that the ketone is the proton acceptor. The ketone is really the base in this reaction. Because it is accepting a proton from hydronium, which is the proton donor and the acid in this reaction. Since the ketone has just one oxygen, we know that is the basic site on the ketone. So we are now using ketone as a base because we have an acid around it. pK of ketone is around 20. If you look closely here, this is the most close functional group to it. And the ketone, so ketone cannot act as an acid because hydronium has a pK of -1.7. So between the two compounds, ketone is going to be the base and hydronium is going to be the acid. Once you have determined that, you're going to draw the arrows. Arrows always move from, when we draw the hydronium near the ketone. Arrows always move from the basic site. The lone shows the movement of electrons, grabs the proton, and electron moves towards the oxygen to give you water. Water is the conjugate base in this reaction. And the protonated ketone is the conjugate acid in this reaction. This is often a first step of a multi-step reaction that you will learn later. So you're just trying to show the arrows if that carbonyl was protonated, what was the actual reagent that was protonating it. It's hydronium that's protonating the carbon because, the oxygen, because when you mix H2SO4 or add H2SO4 to water, all of H2SO4 is converted into hydronium because hydronium is the weaker acid and there is an acid-base reaction within those and the equilibrium moves towards weaker acid. You should know how to draw those arrows when you would like to do that. Always draw complete Lewis dot structure. H2SO4 plus water. Give 0 hydronium. HSO4 minus is the conjugate base, and you form hydronium in the reaction, which is the acid that you are going to use to protonate the ketone. So to summarize, here we had a reaction where we had a ketone reacting in an acidic solution which was made up of water and H2SO4. So we had to first determine which of these compounds would act as the acid. When we have water and H2SO4, we have hydronium in solution. The mechanism of that is shown on the right side in blue. Once you know what's the acid, you know the lone pairs on the carbonyl oxygen of the ketone will act as the base. The lone pair grabs the hydrogen from hydronium to form the protonated ketone and water.